Hello again and welcome back. In this video we're going to discuss a little bit about solving rational exponent equations. And rational exponents are nothing more than exponents that are in the form of, let's say, a fraction. It looks like this. So x to the 3/2, because 3 over 2 are two integers, and when you create a ratio out of them, that is the definition of a rational number. And since they are in the exponent position, then this is referred to as a rational exponent. And some of the equations we're going to solve will look something like this. Let's say I have a to the 5/4 power, and it's equal to 243. We want to find the value of a when raised to the 5/4 power gives you 243. In order to do this, though, you have to remember back to some of your rules of exponents. So let's say I have x and it's raised to the 3rd power. And then I turn around and I raise this to the 2nd power. So I have a power raised to a power. And the solution here then would be x to the 3 times 2 power, which would give you x to the 6th. So this is the power of a power, or power raised to a power rule, whatever that rule happens to be. However, whenever we solve, let's say we look up here at this number right here, whenever we solve, we want to get x by itself. So in other words, you want to get this x to become x to the 1st power, not x to the 3/2 power. So we have to be able to make this exponent become a 1. And we're going to use these multiplication rules here. So you have to take a power and raise it to a power to get a multiplication. But in order to get a fractional number of 3/2 to become a 1, let me go ahead and write this down. 3/2, you would have to raise this to the reciprocal power, which is 2/3. So x to the 3/2 raised to the 2/3 would equal x to the 6/6 power, which is x to the 1st. So these powers end up canceling each other out, leaving you with x to the 1st over here. So we're going to do that on this one. In order to get the 5/4 power to go away, we need to raise this side to the 4/5 power, the reciprocal exponent. So these will cancel out. They'll give you a to the 1st power. But I got to raise the right-hand side of my equation to the same reciprocal 4/5 power. And if you remember back, 4/5 power really means the 5th root. So it's another way of saying the 5th root of 243 raised to the 4th power. Now, if you don't have a calculator, this is the way you'd want to set it up, because the 5th root of 243, I believe that is 3. And then we're going to take 3 and raise it to the 4th power, and 3 to the 4th power should give us 81. So a should equal 81, but we can verify that with a calculator by actually raising 243 to the 4/5 power. So we take 243 and we hit the raise to button, and we're going to raise it to the 4/5 power. So there's my fraction, 4/5 power, and we hit equals, and we can see it does equal 81. But the key to this is, before you raise any reciprocal exponents, the exponent component must be by itself. Give you a little example of that. Let's say we have negative 3m to the 3/2 power, and that equals negative 1029. So you have an exponent here that's a rational number, it's a fraction, but you also have it times negative 3. So you don't want to take the reciprocal power of this left-hand side right now, because you have this number out here. Now, if this was in parentheses, you can go ahead and take the 2/3 power both sides, but you got to get rid of this number first. So you have to isolate the number or the expression that has the exponent before you do the reciprocal power. So we're going to take a 1029, so 1029, we're going to divide it by the 3 that's on this side over here. Let's divide by 3 equals 343. So we know we have m to the 3/2 power equals 343. And so you might be wondering, well, wait a minute, it's negative 1029 divided by negative 3. That's correct, but I know that a negative divided by negative is going to be a positive, so I just ignore that when I do my calculations so I don't make any mistakes. Now that the m is by itself, we can raise both sides to the 2/3 power. 2/3 power. Remember, the reason we raise this to the 2/3 power is to make this m over here become m to the 1st power. So this becomes 6/6, which is 1. And now all we got to do is use our calculator, take our 343, which is on our screen here still, and raise this to the 2/3 power, and we can see it comes out to 49. And you can do this with more and more complex problems if you wanted to. For example, let's say I have 734 equal to x plus 13 raised to the 3/2 power, and then I have a plus 5 on the outside. So our x is inside parentheses, and outside of our parentheses is the exponent. So I want to isolate this whole term before I raise to the 2/3 power, which means I got to get rid of my 5 first. So we're going to subtract 5 on both sides. So we subtract 5 on this side, we end up with 729 is equal to x plus 13 raised to the 3/2 power. That 5 goes away when I subtract 5 from both sides. Now to get rid of the power of 3/2, we're going to raise both sides to the 2/3. Raise both sides to the 2/3 power. Raise this one to the 2/3 power, 2/3. And what happens over here is the exponents cancel out, leaving x plus 13 to the first power, which is just x plus 13. And on this other side, we're going to do 729, and we're going to raise it to the 2/3 power, and we get 81. So we have 81 is equal to x plus 13, and all we got to do now is subtract 13 from both sides, and we can see that x equals 68. Now what you should do is always take your answers here, go back to your original problem, substitute them in, and make sure that this right hand side does actually equal 734.